On behalf of 24houranswers.com, I welcome you to today's lesson. In this video, we're going to look at another example of the mean value theorem, but now we're looking at a cubic polynomial, and it works the same way as we did back in the quadratic example. Except now, again, we have a cubic over here in Desmos, and we're going to restrict this thing from -1 to 1. So I'm going to take this cubic polynomial and I'm going to restrict it from values of x between -1 and +1. Now, if we were to find the slope of the line that connects this endpoint to this endpoint, we want to go back and find the derivative and set that derivative equal to the slope of what we call the secant line. So the line that connects this endpoint to this endpoint, we want to find that slope. And again, back in the first video we looked at, that's exactly what this is telling you to do. y2 minus y1 over x2 minus x1, where those 2 points are your endpoints. Therefore, let's go ahead and find f of b, which is 1. If we call this a and we call this b, b is equal to 1 and a is equal to -1. So f of 1 is going to be whatever we get when we plug 1 into this. 3 times 1 cubed is 3, plus 2 times 1 squared is going to be 5 in all. Now f of -1, when we plug -1 into here, just watch your signs. -1 cubed is -1 times 3 is -3, plus 2 times a +1 when we square that. So -3 plus 2 gives us -1. And back inside of Desmos, we can quickly check that. F of 1 is 5, f of -1 is -1. So with these two values here, f of b and f of a, let's go ahead and find the slope of the line that connects those two endpoints. F of b minus f of a, well, f of b is 5, f of a is -1, so we have 5 minus a -1, watch your signs there, over b minus a. 1 minus a -1, so 1 minus a -1, and therefore we have 5 plus 1 is 6, over 1 plus 1 we get 2, so the slope of the line that connects those two endpoints should be 3. Now the way this is drawn in Desmos, we have to be careful when we check this, but each little hash mark here, like 1, 2, 3, 4, 5, so our y values, these horizontal lines represent 1 unit, and then actually for us to go over to the right or left 1 unit, we have to actually go, 1 unit and then 1 unit. So be careful with that, but we can check our slope here. We said the slope connecting this endpoint to this endpoint should be 3. So I'm going to go up 1, 2, 3 on my y values, and I'm going to go to the right 1 unit. Notice I'm going from -1 to 0. So I'm right here. Then I'm going to go up 1, 2, 3, and to the right 1 unit. And notice we are exactly right on our other endpoint. So we have worked this out, f of b minus f of a over b minus a, and now we want to find some points, some values of c. We may get more than one value here. Let's go ahead and find the derivative of f of x, but I'm just going to use a c to match the mean value theorem. So the derivative of 3x cubed, that's going to be 9c squared if I'm just going to use that c instead of an x. And then the derivative of 2x squared, that will be 4c. The derivative of 2x squared is 4x. I'm just using a c here instead. So now we want to set this equal to this, and that's exactly what the mean value theorem says. Now we are going to have a quadratic equation to solve here. 9c squared plus 4c is equal to 3. Let's move that 3 on over to this side. So 9c squared plus 4c minus 3 is equal to 0. Now this particular quadratic is not going to factor, so we'll have to take the approach of doing the quadratic formula, and just don't confuse these c's here with the quadratic formula where a is equal to the coefficient of our quadratic term, so a is equal to 9, b is equal to a 4, and the c in the quadratic formula is equal to that constant term, so c equals -3 here. Again, do not confuse that c with the variable c here. I know that can be a little bit crazy. So therefore, to solve this, we have -b plus or minus the square root of b squared minus 4ac all over 2a. Now I'm just going to go to the TI-84 here to get this answer. I'm not worried about an exact answer. We can just round this off. Therefore, one of our values is roughly this right here, and then we can just bring up that same rational expression thing, the quadratic formula, and I'm going to change that -4 plus to a -4 minus, and this is our other value. Now, do we want to use both of these values? And the answer is yes. The reason why we want to use both of these values is because both of those values fall between -1 and 1. So we're looking somewhere roughly around 0.4 for one of our x values, and somewhere roughly around -0.8. And these are our two c values. What this means is, if we think about this slope here of 3, connecting these two endpoints. Now, looking at how our x's are spaced out in Desmos, we have 1, 2, 3, 4, 5 spots. That means each one of these little x values here represent 0.2. So here's 0.2, here's 0.4. If we were to imagine putting a dot right here and drawing a tangent line to that dot, it would be the same slope as this one. That would be that 0.396, roughly around 0.4, right? Now let's look at this one. This one's kind of close to -0.8. So going to an x value of -0.8, that's -0.2, -0.4, -0.6, -0.8. The dot right there, roughly somewhere in here, if we found the equation of the tangent line there, that equation of that tangent line would be parallel to the one right over here, close to 0.4, and that would also be parallel to this secant line. So we're technically finding two c values here because there are two spots where the slopes of those tangent lines are actually equal to the slope of the secant line connecting the two endpoints. Now, one thing to keep in mind as well with the mean value theorem, your function needs to be continuous over that interval, and we have a cubic polynomial which is actually continuous everywhere, so we don't have to really worry about discontinuities, and a cubic polynomial is also differentiable over its entire domain. So with those things in mind, it was no problem tackling that without necessarily addressing that at the beginning. But be careful when you're dealing with other types of functions that do have discontinuities or points on the curve where the function is not differentiable. If that falls anywhere inside of that interval, then you cannot use the mean value theorem. And that's exactly what we'll explore in a future tutorial. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.